The instrumentation amplifier for Lab 8. First of all, what we're going to do is add the components. So let's add LT1001. So we have 3 amplifiers for the instrumentation part. Now we need the resistors. So if you press Ctrl R, you can rotate the resistor like this. I'm doing this on Mac. It might be a little different on the Windows. So now let's start wiring the components. First of all, let's connect the outputs. Make sure you see the connection intersection over here. Likewise over here. Sorry. I'm just keeping this terminal open so that it might be used for the further purposes. And now the important task is to add the internal connection. Let's keep open wiring for the input signals. Again, right over here. So now let's start adding the values to each component. Make sure you click right at the resistor and then change the value by right-clicking it. So this is 100K. This is the RG, which is 2K. This is again 100K. This is 10K. This is 100K. This one is 100K. And this one is 10K. So now we are almost done with the circuit, but now most important thing is to add the power supply unit for this. So let's add the power supply components. We are going to do this separately. So if you see the VCC over here at the U1 plus VCC is over here and minus VCC is over here. So we're not directly going to connect it to the power supply over here, but we are going to add the components, and I'll show you a technique how you can use just the connections or the net connections that can enable the connections to the power supply. So let's do that. So we need a voltage source. Now we actually need a couple of voltage sources. So there's one And this the second one. Also, we need to add the ground. Let's do it over here. Also, we need one over here. And finally, the wiring part. And this goes up. This is going to be our minus VCC. So let's first of all right-click over here at this node. You click Label the net, and let's write VCC plus, and let's call this as, click over here, let's call this as VCC minus, or minus VCC. You need to change the values over here. We're going to use 15 volt power supply. Again over here, 15 volt. Now if you look at the plus VCC, they are right now open. So let's learn how to connect them. You just add a short wire from here. Again, a short wire from here. Again, another short wire from here. So you have to do this for everything. For every op-amp. From here to here. Okay, good. So again, you have to do the same thing. Right-click over here, label the net as VCC plus, which means that this power supply will be associated with this one. And again, right-click over here, label net. Let's type VCC minus. Make sure the spelling is same as what you have written over here. Again, the same thing over here. Let's call it as VCC plus. And this one is VCC minus. And finally over here, label it as VCC plus and VCC. Okay, now we are almost done developing our circuit. What we need to do is add an input sine wave. So let's add a voltage or a sine wave component. So let's type sine. We add it over here. Now let's change the parameters. So the parameters are going to be, first of all, the DC update voltage will remain same. The gain of this amplifier is pretty high. You need to figure that out. So we are going to give an input of 5 millivolts or 0.005 volts. And the frequency is going to be 100 Hertz, or as mentioned in the description. Also, we need to add the wire to this connection. Let's do that. And the final thing is, in the Mac, you need to add the time slot. So to do that, you go to Draft, you add Spice derivative, and it will be done. Well, let's make it for 1 second right now because it's 100 Hertz. It's going to be really quick. So add it over here. I purposely create a box around the power supply by drawing rectangle. So I draw the rectangle this way. I make it look dash. And also add a text by clicking T, and let's call it this as power supply. So just write it over here. This doesn't have any purpose other than making it understandable for the end user. So now let's try to run the circuit. Okay, it's right over here. So first of all, let's check the input signal, and that can be done by clicking over here. So you see this is the input signal, which is of 2.5 millivolts. So the input 5 millivolt wave was peak to peak. So this is 2.5 millivolts. Now the second thing which we'll be doing is checking the output terminal, which is right over here. So I click it twice and look at it. Okay, so it's amplified almost 1,000 times. It's 5 millivolts. So this part is functional. Now let's again add a box to it. By clicking W, we can add a rectangle. And let's call this component as, by adding text, let's call as Instrumentation Amplifier. Okay, so let's add a design over here, or level this net as Instrumentation Output. Now this junction will be essential when you're going to give an input to the bandpass filter. So now let's design the bandpass filter over here. From the design, again, we choose LT1001. Now we need 2 resistors and 2 capacitors. So let's go once again to the cap. So capacitors, again, hit Control R. We're designing this component will add for the low pass. There's the high pass. Okay, now we need to add resistors. Control R. And run in parallel. Okay, good. So let's add the wiring to this function. And over here, we add another small wire. Now this instrumentation, you can directly connect a wire from here like this. You can take this wire and connect it to the bandpass filter. This is one way. Or the other way could be use the level name or the net name. So I'll delete this part by hitting F5. And again, let's change the name to the same what we labeled over here. It's called as Instrumentation Output. Yeah, this cannot be input. It will be the same name as what you have given to the previous terminal. That's it. So now let's change the values of the resistor, which is 5K in this case. The capacitor is 100 microfarad. This capacitor is, again, 2 microfarad. And the resistor over here is 5K. Okay, so now let's run again this program and see what's the voltage at the output end. Okay, so one thing which went wrong is we didn't actually connect this to the power supply. So we need to add the wires and connect this part to the power supply. So let's label this as VCC plus. This will be VCC minus, and let's run it again. Okay, I'll try to So what went wrong over here was the spelling was written wrong. And now I've corrected it. Let's try to run it once again. Let's test the input first. So the input is 2.5 millivolts and 5 millivolts peak to peak. Let's test the output at the instrumentation end, which is again 10 volts peak to peak. So it's actually 2000. Gain is 2000. Now let's check over here if you're actually getting the same signal what we should get over here. And it's the same one, so it's 5 volts. So now finally at the bandpass filter, we see that the signal is something like this. So you'll have to answer it why it looks like this. That's the first part of the video. Now the second part is to change the source and use a different source, or you'll be using the real ECG waveform. So to use that one, all you have to do is click the style, click PWL file. It might look a bit different in Windows. Browse to the file and use the file .ECG. The file might be called a bit different. Hit OK. And now let's try to run it once again. So if you check the signal over here, oh wow, it looks like a good waveform. So now the signal is in -2 millivolt to 5 millivolts, so the amplitude is roughly around 7 millivolts. Now let's check how the amplifier did its job. Okay, so it actually amplified to a lot of degrees, so it's like 14 volts is the amplification, peak to peak. What you can see over here is there's some kind of noise in this signal. So we want to verify if this noise has been removed. You can also notice that the signal is inverted as compared to the input one. So let's also test it over here at this end. And the signal looks same. Finally, let's check it at the filtered output. Now you can compare. It's the same amplitude, or the amplitude is reduced a bit, but the noise is also removed. So that's how our filters work, and that's the short tutorial for this course, or the lab 8. Thank you guys, see you.